Hello to all my viewers. This is Dr. Dhaval Maheta, and today we'll understand how to run non-parametric test in STATA. Non-parametric tests are statistical methods that do not assume a specific distribution that is a normality for the data. They are also called the distribution-free test and are used when the data violates the assumptions of parametric test. When to use non-parametric test? First, when the data is not normal. That is, the data is skewed or it follows a non-normal distribution. Second, the data is ordinal, that is rankings, Likert scales or categorical orders. When the sample size is small, we go for non-parametric test. When many outliers are present, so the non-parametric tests are less sensitive to extreme values because we consider the median in it. Heteroscedasticity. When we are having unequal variances between the groups, we go for non-parametric test. For every parametric test, we are having a non-parametric equivalent. So for independent t-test, we are having the non-parametric equivalent Mann-Whitney-U or Wilcoxon rank sum test, which is used to compare two independent groups. Paired t-test, Wilcoxon signed rank, and here also compare two related matched groups. One-way ANOVA, Kruskal-Wallis, where we want to compare more than three independent groups. Repeated measures ANOVA, the Friedman test, when we want to compare more than three related matched groups. Pearson R, and here we are having Spearman rule, used for correlation for nonlinear relationships. Now, first of all, we will download the data. So we'll go in Google. I'll write here HSB2 CSV dataset, enter. Now click on this link, open intro HSB2. So this dataset consists of 200 observations randomly sampled from high school and beyond survey. It's a data frame with 200 observations and 11 variables. The variables are gender, the categorical variable, and its label is female and male, you can see here. Race, its label is African American, Asian, Hispanic, and white. Socioeconomic status, low, middle, and high. School type, public and private, public and private. Program, general, academic, and vocational. Now we are having the scores, the reading scores of the students, writing scores of the students, math scores of the students, standardized science scores, and standardized social studies scores. I want to download this data. It's very simple. Just click on this CSV file, done. And the data will be downloaded in downloads. Now go in STATA, click in file, import, text data, click on this browse button and click on this HSB2, open. Click OK. On right hand side, you will be able to see all the variables. But still, I insist that you run browse command so that you can see the entire data frame. So gender, race, socioeconomic status, school type, program, reading scores, writing scores, maths, science, and social studies. The first test which we want to run is Wilcoxon rank sum test. Now what is this test? The math scores we want to compare with the gender. That is there any significant difference in the math scores according to the gender or not? So we were running independent sample t-test when our data was normal, but here our assumption is that the data is not normal, and therefore we are running Wilcoxon rank sum test. Now close this. Now go here, write the command rank sum math, that's a math score, by gender. Enter. What is our null hypothesis? The null hypothesis is there is no significant difference in, please remember this word, there is no significant difference in median. In the median of the median scores, the median math scores of male and female. Now just see this p-value. As this p-value is more than 0.05, we fail to reject null hypothesis, which means that there is no significant difference in the median scores, in the median match scores of male and female. We can also further confirm. We can also further confirm with the help of summaries. So I'll go in statistics, summaries and descriptive statistics and summary statistics. Now activate the math here. See, you will have to activate the math here. Just click here, math, go in by, activate this repeat command by groups, select gender and press OK. So you will get the mean match scores of female, mean match scores of male. See, the difference is not so large, you can see. The same command we can also run with the help of graphic user interface. So we'll go in statistics, summaries. In summaries, non-parametric test of hypothesis. In this, we are having two tests, Wilcoxon matched paired sign rank test. This is dependent. It's an equivalent of dependent t-test. And this one, Wilcoxon rank sum test. This is the equivalent of independent sample t-test. So click on it. So what is our target variable? Target variable is maths. What is our grouping variable? The grouping variable is gender. Display the p-value and submit, and we got the results. See, we got the same results. Now let's proceed further. We'll work on the same data set. I'll change the name of two variables. So rename reading scores as before and rename writing scores as after, just to make you understand that what is a dependent sample, not a dependent sample t-test, the non-parametric part of the dependent sample t-test. So enter. I will have to make it rename. So we are having before and after. Now let's run the command non-parametric test for dependent sample t-test, non-parametric, and here we'll be running Wilcoxon matched sign rank test. So here sign rank before and after. What is our null hypothesis? There is no significant difference in the scores of the students before and after the training program, before and after the training program. Enter, and we got the results. Just see here. As the p-value is more than 0.05, we fail to reject null hypothesis, which means that there is no significant difference in the scores of the students before and after the training program. We can also get the summary again, statistics, summaries, and summary statistics. And in this, we will run before, we'll activate before and after, and press submit, and you can see here gender sorting is on. Let's remove it, that will be better. By remove the stick, submit. Okay, so before and after. I can also generate the summary with the help of this command, summarize directly from here, summarize before and after. Now I can run this test with the help of graphic user interface also. So I'll go in statistics, summaries, non-parametric test of hypothesis, and this time I will run Wilcoxon match pairs signed rank test. Click here, variable before. So activate before here, and here it should be after, and press submit, and you've got the results. See, you'll get the same results, signed rank before and after. Now again run the command browse. Now I want to compare the match scores according to the program type. See, here the levels are three: vocational, general, and academic. In the previous case, the levels were only two, male and female. And here the levels are three. So whenever we are having more than two levels, we will run Kruskal-Wallis. So math scores compared according to the program type. Close this. Go in the command window and write the command K-Wallis. It's a Kruskal-Wallis math by program. Enter, and we got the results. See, academic, general, vocational, the rank sum. What is our null hypothesis? There is no significant difference in their math scores. Basically, we are working on median only. There is no significant difference in their math scores according to the program. But you can see in this p-value, it's less than 0.05. This means that there is a significant difference in the math scores according to the program. Now, to see the difference, what we'll do, we'll go in statistics, summaries and descriptive statistics, and summary statistics. Remove this part, activate math, go in by, and here instead of gender, activate program and press submit. Now let's compare it. See, the mean math scores of academic program, the mean math scores of general program, that is the students who have opted for general program, this is academic program, and this is the mean math scores of those who have opted for vocational. So the students in academic are scoring highest in mean maths, and here they are in vocational, they are scoring lowest. Now here the comparison is on the basis of mean, but please remember that the test runs on median. Please don't do this mistake. Okay, it runs on median. Now let's proceed further. Whatever we have generated with the help of command user interface, that the same thing can also be generated with the help of graphic user interface. So what I will do is I'll go in statistics, then summaries, non-parametric test of hypothesis, Kruskal-Wallis rank test. The outcome variable is math, variables defining the group is program, and press submit, and we got the same results. You can see this summary which we have generated with the help of graphic user interface. This summary, it can also be generated with the help of command user interface. So what I write, by short program, comma, short, summarize, math scores, enter, and we got the same results. Now we want to run the correlation between maths, science, and social studies scores. And here we will run non-parametric test, which is a spearman. So read math scores, science scores, and social studies scores. So I'll write here SOST. You can see the name of the variables from here and just press enter. So we got the results. Math, that is a correlation between science and maths, correlation between social studies and maths, correlation between social studies and science. The same thing we can also run with the help of graphic user interface. So go in statistics, summaries, non-parametric test of hypothesis, and spearman rank correlation. Select the variables, math, science, social studies, and just press submit, and you will get the same result. There are some more statistics. If you want, you can activate from here, display correlation coefficient, and display the p-value. Press submit. So what is a null hypothesis? There is no significant correlation between maths and science scores. And as the p-value is less than 0.05, we reject the null hypothesis, which means that the correlation is significant. Remember, don't forget to speak Spearman correlation. So the Spearman correlation is 0.64 and this is the p-value and it is less than 0.05. Now this is the correlation between maths and social studies. Its value is 0.54 and the p-value is 0.00, so which is less than 0.05. We reject null hypothesis, which means that the Spearman correlation is significant. So this was all about how to run non-parametric test in STATA. For more videos on STATA, kindly refer to my playlist. I have also uploaded many videos on data science, machine learning and artificial intelligence on my YouTube channel named Dhaval Maheta. To watch the full videos, please subscribe to my YouTube channel and check the playlist. Please don't forget to like and share my videos. You can also follow me on different social medias, link given in the description box.